This project, Toon 3D, is best described by showing. So before I say anything, let me show you one video. Just watch it for 10 seconds and then try to realize what exactly is happening here. This is the first clip. Let me play the second one. Now let me play another video, just one of it, and then you will see I'm playing this second row first one, and I'm moving the camera. Okay, so the thing is that humans typically have little trouble inferring the relative camera poses and 3D structure from hand drawn cartoons. If we go back to the first page, on the very left hand side we have hand drawn images. Then secondly, they have been labeled by Toon 3D into correspondence, which one is transient mask, and then which one has a predicted depth. So if you look at this one, Toon 3D takes a set of geometrically inconsistent images with correspondence and predicted depth maps and creates a consistent 3D model. This is being achieved by warping the images in 2D and solving for camera parameters by aligning back projected point clouds. The images are warped to fit a perspective projection. With Toon 3D, we can visualize cartoons from novel views and analyze geometrical inconsistencies in the drawing. So humans typically have little trouble inferring the relative camera poses and 3D structures from the hand-drawn cartoons. But current structure from cartoon or SFM pipelines fail to reconstruct these scenes because the images are not geometrically consistent. Secondly, the images do not obey physically plausible camera models, and then the scenes are typically only drawn from a sparse set of views. But in this work, these researchers have overcome these challenges by proposing a non-rigid, piecewise rigid deformable optimization framework, which you can see on your screen. This framework recovers camera poses and dense structure from non-geometrically consistent images. They have constructed a plausible 3D structure for hand-drawn scenes, and the deformed input messages obey a perspective camera model. There are various other examples scattered throughout it. We already saw this one. Now, let me play this one. In this one, the cartoon has been restructured, and this is a fly-through renders of their scene, by the way. So, what they have done is they have proposed a pipeline that consists of three main steps. First, sparse alignment. So the pipeline takes a set of correspondence as input, which they back project into 3D using the depth from a monodepth network. And then they align these sparse correspondences in 3D to coarsely estimate the camera intrinsic and extrinsic parameters. They have also included dense alignment. Starting from this camera configuration, they initialize a 3D mesh at the sparse correspondence and deform its vertices until achieving near perfect alignment at the 3D correspondences. They regularize their warps with 2D and 3D rigidity losses to prevent degenerate solutions. So for example, if you look at these videos, I'll stop the top one. If you look at this one, and if I toggle the cartoon names here, you see, let's play this one and then SpongeBob and maybe Simpsons all together. Let it run for a second and just keep looking at it. And now let me uh, toggle the cartoon names. Now, can you guess which one is which. For that, maybe for example, you click here and then you can just stop and check it out. So I will toggle the cartoon names, and can you guess which one is that now? You see, so now they have produced the names and you can easily tell too. So amazing stuff. Also, if you look at this method, they have described what I have just told you about sparse alignment, dense alignment, and all that stuff. In addition to this sparse alignment and dense alignment, they they can use their aligned mesh with barycentric interpolation to densely warp the RGB images in 2D and the depth map in 3D. They have also done the Gaussian refinement by densely aligning point cloud to initialize 3D Gaussian splatting to enable a more immersive visual experience than point clouds or meshes. Another cool thing is, and these are, for example, a few of the examples of dense alignment and sparse alignment, as you can see on your screen. Now, another cool thing is that they have proposed a Toon 3D labeler, which is a user-friendly annotation tool where a user can label point correspondence between images while segmenting transient objects. The Toon 3D labeler is a hosted website with no installation, so anyone can get up and running with it easily. They also have intentionally highlighted Toon 3D labeler as a contribution of their paper because artists work with cartoon drawings regularly, and this tool fits nicely into human in the loop framework for recovering 3D from these drawings. And that is what I really like about this, that it seems that Toon 3D is a step towards achieving a qualitative 3D understanding of cartoons. Humans can perceive scenes that are not necessarily 3D consistent, but current algorithms cannot process such imagery due to non-perspective or non-consistent drawing. So that is where this really shines. I think this is going to really change the way we create and we perceive cartoons. As I mentioned earlier, there are a lot of other examples which you can check out. These are different cartoons. So for example, if I click on this one and let's wait for it, and they will be showing the point cloud and all that stuff. Just wait and it is going to load. There you go. See, this is a point cloud from that screen. So for example, if you click on this one and then just wait, and then you can play around with that 3D scene once it appears. There you go. How good is that? And there are various other examples which you can check. We already have seen this one. And then this is video and images in different original difference and warp sense of the way. So anyway, all in all, a real good project in my humble opinion. They have also shared the code in the GitHub repo. They also have a full-blown demo if you are interested. And then they have the archive paper on this project page. So go through it. Let me know what do you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.